Hey, hi everybody. Hope you're all doing well. So after talking about the circular economy and industrial ecology, I think it makes some sense then to talk about eco-design strategies. Or how are we going to get to, better design so we have fewer environmental and social issues? So let's start with this. This is not a new thing. It's been around for a while, this idea. So in 1992, the United Nations had a conference in Rio de Janeiro, and what they adopted was called Agenda 21, the Rio Declaration on Environment and Development, and it was adopted by over 178 governments. And what they determined was this agreement that the world is on a path of energy production and consumption that cannot be sustained. All right, no surprise to everyone in this course, right? And so what was important about this, though, is that it drew attention to the development strategies that could be effective in world economies and trade policies. So now that they determined and agreed on what the problem is, the next step was action. So they encouraged development of how to make products better and how to reinvent design culture, like how do we design products that are consumed by everyone. So this Commission on Sustainable Development was created in '92 to follow up on these findings and to monitor improvements. So let's look at this. I think this is the biggest statement about resource use, and because what it shows is that there's been this increase in global waste production, and whether it be an LDC or an MDC or somewhere in between. This here describes each one of these curves, but you can see this increase. So even as we have an increase in the consumption of goods in lesser developed countries, which helps reduce poverty, so we have more affluence in LDCs, there's more consumption and there's more disposal, which means that everything becomes either a resource or a pollutant, and in this case you see the production of pollutants. So consumption in open loops, that's the problem. And so how can we get out of that problem or reduce it? It's through design. How do we design products better? So what I'm talking about here, it's critical to understand this is on the industrial level, because after all of us are merely consumers. We consume what industry produces. Industry then, their processes and designs, they determine the amount of pollutants that are going to be created by our consumption of their products. So that's what this point here is about eco-design. It's in this approach to designing products with special consideration to reduce overall environmental impacts. So that means the physical impacts, of materials, and then also with energy. So energy and materials. So what is that? It means any form of design that minimizes environmental destructive impacts by integrating itself with processes, living processes. That's a definition. So it recognizes and acts on this awareness of negative impacts of overpopulation, industrialization, and growing economic areas of the world, right? Okay, so we consider, or it considers, impacts throughout the supply chain, which we will get into, and it also considers end of life, and that means the end of the life of the product. So, we've learned that everything's connected to everything else, right? So the circular economy then is trying to close these loops, basically mimicking biological systems, so that you end up creating, rather than having cradle to the end of the product, meaning waste, right? It's cradle to cradle, meaning goes from the beginning back to the beginning. So it mimics life cycles. So materials have impacts, right, on all aspects of the life cycle of a product. So this cradle to grave, which is what I was trying to say in the previous slide. Sorry about that. So how do we evaluate things? Well, there's the real cost, right? And then there's the cost to society. Real costs are things like the products end up going into landfills. People have to pay those landfill fees. So that is, you and I pay that fee. Government, we also pay taxes that have government employees that manage all this stuff. We have whole private sector systems that manage waste and garbage and the pollutants that come from managing landfills. So all of those costs are real costs. And then there's the societal cost, meaning the health impacts from all this, the waste of these materials. So that includes stuff like there's a production of methane that comes from when we create waste and disposal. So industry doesn't pay these costs. We do. And so one of the ideas here is that if you create less of a problem at the beginning, then with how industry behaves, then all of us have a reduced cost. So there's actually a less cost to government, less cost to individuals. So what I'm basically saying is that it's back to that economic term we talked about earlier, internalizing externalities, meaning industry pays for the cost that the social and environmental costs that it creates, and then by doing that, they take that burden away from individuals and local governments. So how do we get to this eco-design strategy? Well, you would be looking for having abundant, non-toxic, non-regulated materials. Regulated meaning regulated by government. Natural materials over synthetic. You would be designing products for minimal use of the materials, and you'd look at the processes and services and trying to get the most out of those materials and energy. In other words, all of this is about efficiency. How do we move towards more efficient means of doing business? And for business, essentially what that also means is reduce cost, right? So if they can reduce their costs, they can increase their profits. So how do we also, more information about selecting low impact materials? Well, we'd want to avoid hazardous materials. Can't always be avoided, but you do it as much as we can. Selecting low impact materials, cleaner production processes, maximizing efficiency of energy and water use, designing for waste minimization, using local materials, using certified green building materials, and there's different certification programs that are out there. And then using recycled content, so use recycled materials to make new materials, and then to make your product recyclable, and then also using reclaimed materials when you can. So let's talk about some of these components of eco-design. So I've made a list here. Design for the environment, dematerialization, design for disassembly, TQM or total quality management, biomimicry, design for remanufacture, eco-industrial parks, and extended producer responsibility. Okay, so let's talk about the first one, DFE, design for the environment. So that considers all of the potential environmental impacts that a product and its components has on the environment. So you would use DFE to reduce the quantity of materials. You would try to include recyclable components. You would reduce or eliminate hazardous components, all those things we talked about earlier. So it considers the entire life cycle of a product and all the energy that was used, as well as the materials, the packaging, transportation, the use of the product, and then its end of life. So we would consider stuff like, can the product be recycled? And so you can see that it's really effectively integrated with this concept of industrial ecology. So the U.S. EPA has recognized the importance of this, and so it started a design for the environment, an award and a promotion. So it's a voluntary program that it's established, and it evaluates these products and the manufacturing processes, businesses that would be applying for this DFE label. And there's over 2,700, closer to 3,000, might be more than that now, that have this DFE logo. So also on the industrial side, not just with government through the EPA, but there's this National Center for Manufacturing Science. And so they started a program about environmentally conscious manufacturing. And since then, that the manufacturing programs such as compliance assistance centers, sustainable product design initiatives, alternative energy technologies, all these things have been incorporated. So industry is also working with itself to improve these systems. So the next one be a dematerialization, and it's just what the word says. It's a reduction in the quantity of the materials that would be used in making a product. It's basically what it means is doing more with less. There was this concept that had come up from Buckminster Fuller, an inventor from decades ago, who really got people starting to think about this. He used this word ephemeralization, right? Now we've made a simpler term, simply called dematerialization. Okay, next one is biomimicry. Basically, what it is saying that, you know, the most efficient operations are those that are created by by nature, and we just copy nature. Now you can see here, like fins on animals like the shark, and the wings of birds are mimicked on products and materials that that manufacturers use. As the comic points out here, there's been 3.8 billion years of R&D, research and development. So rather than trying to do it on ourselves, why don't we learn from nature? That's the concept here, is that nature can inspire human innovation. The next one is design for disassembly, and again, that means exactly what it's saying here, but how you design products so you can take them apart. Now you think, like, why would you do that? Well, it's so that you can repair parts, right? You can replace bad components, you can repair other components, and so there's remanufacturing. This diagram over here shows you about, like with carpets, you can have a component of a carpet that is stained and then can be removed and replaced, and you don't have to replace the entire carpet. That actually came from a carpet company whose the idea was to do that, because the owner of that recognized the negative environmental impacts of their product, and he wanted to reduce the scope of that problem. So the next one is total quality management, or TQM, and it was developed by William Deming, very well known in history. He was brought into Japan after World War II and converted essentially their economy to become one of the biggest in the globe not long after World War II, and by applying this concept of total quality management, and it was so successful, then you had other countries and businesses that also adopted this policy. And basically what it is this continual process of detecting and eliminating errors and reducing errors and streamlining the supply chain. So efficiency again. And the fourth component was improving customer experiences. And then the last one was ensuring that employees are up to speed with training. I can't tell you how many government organizations that I've been part of, and even at the universities, where you have new people coming in that have no information whatsoever from the previous generation who's been doing things, and so there's a loss of a lot of institutional knowledge, and then that makes everything move slower. Well, with TQM, you would encourage this flow of information so that everyone can learn more from the previous group who have learned things and learned how not to do something. And by doing that, they learn how to do something with more efficiency. So, bottom line with TQM, it aims to hold all parties involved in the production process accountable for the overall quality of the final product or service. And there's an organization that actually works to do just that, and it's the ISO, the International Organization of Standards, and which we have a lecture on later in the course. The next thing here is extended producer responsibility. It's fairly new. Actually, one of my former students was very involved in creating a state organization. So essentially what it is well, what he recognized, he worked for government, recognized that government had a significant cost in managing things like paint and electronics. And he thought that, government shouldn't be paying for this. The industry that created the problem, they should be paying for it. And so through his work and the work of others, legislation was adopted to then create rules and regulations for industry to take back paint, mattresses, some electronics, cell phones, for example. And all of this then is known as extended producer responsibility. And the idea is to reduce the cost to the local government, reduce or eliminate the cost to the public by having industry take back the materials that it has created. And by doing that, it creates an incentive for industry to make their products less toxic. So quite I think highly of this of the concept of EPR. So the next thing here is in supply chain. So with supply chains, we'll look at the how industry can affect a supply chain to reduce impacts throughout the supply chain. So the supply chain is about, you see here, the manufacturing of a product and distribution and retail and accepting raw materials and different suppliers. There's all this stuff that goes around and around. And so there can be a reduction throughout the supply chain when it's determined by the purchaser for that to happen. So let's talk a little bit about plastics, because plastics is something that excuse me for that. Wait a minute. Oh. Okay, so let's talk about plastics. Plastics are a significant problem in the environment. I'm sure, as you know, they're persistent. They take oftentimes decades or centuries for them to degrade. They're a significant pollutant in waterways, fresh waters, and oceans, and lots of animals have been dying because of ingestion of plastics and confusing them with foodstuffs. So let's understand a few things about plastics and what we can do about design to use less of it and to use them better. So we know that plastics are made primarily from petrochemicals, meaning from oil, right? They're a polymer. Different polymer chains result in different types of plastics. So plastic is very different from one type to another. There's literally hundreds of them, if not thousands of types of plastics. So the first plastic was the stuff celluloid, and we still use cellulose, and it was used to replace ivory in billiard balls. Good idea, right? We shouldn't be shooting elephants to make billiard balls and piano keys. And the first mass-produced artificial plastic was Bakelite. And then there were other early plastics like nylon and polyvinyl chloride and polystyrene and polyethylene. So here's a diagram of the plastics manufacturing process, essentially extracting petroleum and then making monomers and then polymerization, different additives to create different types of plastics. Then consumers use them. Some of it gets recycled. It's very, very little, probably 1 to 3% total. And so where does most of this plastic stuff go? Into waste. So there's different types of plastics. As I mentioned before, there's literally hundreds. The plastics industry, in response to criticism back in I think it was the 80s, came out with this numbered system and giving people the idea that plastic can be recycled. So this is largely false, because things can only be recycled if there's a market. So there has to be an organization, industry, that will purchase plastic and then be able to make recycled plastic to be made into new products, which also means then there has to be an entire system of collecting plastics and separating plastics and cleaning plastics so that then they can be marketed. So most of them tend to be, or the industry came up with these 7 numbers because what they do, they indicate the largest types or quantities in these particular types of plastics. So there's PET. A lot of soda bottles are made with PET. Then there's HDPE for like milk containers, PVC, that's ponyl vinyl chloride, and then you have low density polyethylene, LDPE. That is used in a lot of plastic bags, one-time use plastic bags. Then there's polypropylene. That's made for a variety of different products. And then there's number 6, PS, which is polystyrene, something that you've seen quite a bit. So basically the foam containers. There's been a lot of government action, particularly in Santa Clara County, to ban that. That was because that when polystyrene breaks down, there's these little, they're called nurdles, these little round parts that then get confused by animals and used for as food. And then there's number 7. Number 7 is everything else, right? Everything else. And there's literally hundreds of this. So I can tell you, frankly, I get really annoyed with some local governments that said that they accept plastic number 7 for recycling. I can tell you they absolutely do not, right? There's no markets for those. In fact, there's very few markets for 3, 4, 5, 6, or 7, any of these plastics. All right, we'll move on to the next one. So let's talk about some of these impacts of plastics. So we've got polystyrene, which has benzene, a carcinogen. It uses lots of energy to produce. There's the high-density polyethylene, HDPE, and low-density polyethylene, LDPE. They both use ethylene from natural gas or oil. Lots of carbon dioxide and sulfur dioxide that's emitted. Then you have polypropylene, also from oil refining, creates some solid waste. You have polyethylene terephthalate, that's the PET or number 1 plastic. Uses ethylene glycol and terephthalic acid from petroleum. And you have polyvinyl chloride, which is a definite carcinogen. Don't chew on that stuff. It's used in a lot of pipes, frankly, and basically to move water. So it has chlorine and ethylene from natural gas. You see quite a bit of this stuff, polyethylene. It's rather inexpensive. And then you have biodegradable plastics. So this concerns me quite a bit because you have a lot of people talking about the benefits of biodegradable plastics, and frankly, they're just not there. And I'll tell you why. The number 1 problem is that it's this continual concept and this belief of throwing things away, linear, right? So that, like, oh, we wouldn't have to worry about plastic because if it's biodegradable, it'll go into the environment and then magically disappear. But I can tell you that's not how it works. And there's extraordinarily small amount of this stuff that's made in the first place. So at any rate, let's get into this. So this concept is that it's a wrongly thought of solution to a problem, right? So the problem is, of course, plastic that is that becomes litter and is discarded and ends up in oceans and rivers. Much of the stuff you see in the oceans are, frankly, they're not from the United States. They're from Asia, where they don't have the sophisticated waste collection programs that we have here. Okay, so there's this problem where people see the problem of waste, and so their solution, and that some industries are trying to take advantage of, and frankly, there's environmental people who don't know what they're talking about, thinking that biodegradability is a better solution. It is not. So yes, biodegradable stuff would decompose from UV light, ultraviolet light, which comes from the sun, of course, and then water, bacteria, enzymes, all the typical things that's needed for anything to decompose. What some of the product manufacturers do is they add starch as a filler to promote breakdown. However, when that happens, you still get bits of plastic made from polymers, right? Chemical polymers. So one of the key things that is the biodegradable plastic all entirely biodegradable, or is it half plastic from polymers from oil and another part starch? And so the next part here is this, that these biodegradable plastics will not biodegrade in landfills. And why won't they biodegrade in landfills? Because there is no light, there is no water, there is no bacteria, or very little, and there's very little, few enzymes. So one of the key problems here is that many people believe that things go into landfills and they decompose. Well, I can tell you from being in this industry for decades that that the whole point of landfills is so that there would not be biodegradation. They are designed to divert water from material that's buried, so therefore you have no anaerobic decay. Stuff largely does not biodegrade in landfills. They just become toxic soups. More about that later. So the other problem then is that biodegradable plastics contaminates recyclable plastics. So when you have recyclable plastics, they can be separated and then marketed as a product that can be then remanufactured into new products. If you integrate biodegradable with this, now you degrade the quality of that product. And I can tell you that there's nobody at the sort line at recycling facilities that's going to be separating or taking the time to look at a little green stripe on a plastic cup to figure out that the thing is biodegradable, and then to pull that out and not have it mixed with the other types of plastics. So it's kind of a fantasy to think that biodegradable plastics are going to be an answer to this type of thing. What I'm getting at is that what really has to happen with plastics is frankly creating markets for recyclable plastics. Okay, so there's a good material, Plastarch material, or PSM. It's a modified cornstarch. It has other biodegradable materials in it, and it can be broken down by bacteria and it's stable in the atmosphere, but it's only going to biodegrade with compost. You have to have all those elements: UV light, water, bacteria, enzymes, what have you. And there's you can find packaging and utensils and bags and things like that that are made from this biodegradable plastic. So there may be an application for this, but I think on a large scale, absolutely not. So some of the benefits of plastics, it's easy to knock plastics, but I want you to understand that there's a reason why we use them. Same thing as anything with capitalism. Why do we use it? Because it's cost effective. So plastic is very lightweight, so it's easier to, or costs less to transport your product in plastic. Also, plastics do a really great job of protecting products. Many products last a lot longer because of plastics, and you can use fewer materials. So, for example, candy bars. Candy bars used to be in a paper wrapper, and the candy itself would be sitting on a paper tray. Well, no longer do we use the paper tray. No longer do they use the plastic or paper wrap. It's just a single type of a plastic wrap, and the candy can actually last longer and has much less environmental impact, because there's less environmental impact, believe it or not, in the production of plastic than paper. More on that later when you do a project on this. So plastic, basic benefit is that it's lightweight and reduces cost of distribution, and it's very efficient. So where do they get plastics for recycling? Well, the first step is really from industrial sources, manufacturing scraps that are collected and used on site, post-consumer industrial waste. So that means that's after the consumer uses it, and industrial products that have been used and discarded, like plastic bags and crates. And then you have post-consumer domestic waste, so that's packaging. So that's harder to recycle, because it has to be collected and separated, and then hopefully and you never know if the public has actually separated this stuff correctly in their recycling bins. So it's a challenge, but it's something that we've been rising up to meet. So it becomes increasingly difficult as it gets closer into consumer hands. So the design strategy for plastics then would be using plastics that have less impact on the environment. So some have more impact than others. So you'd want to use stuff that does not have the carcinogenics. You would want it to use stuff that plastics that have a significant amount of recycled content, and you'd want to use as little as possible, so you could take advantage of lightweighting. And then lastly, you'd look at stuff like you'd want to use plastics that have a strong recycling market, so that industry then would not have to be responsible for that product, but that the industry that manufactured the product wouldn't have to be responsible for it taking it back, because there's there would be an established and mature recycling marketplace that could then take that material back and then recycle it and then make it into pellets that then can then be resold as a resource. Okay, so now let's talk about timber. So forest lands, right? Natural material, obviously. Harvesting, we know, has significant impacts, because when you harvest timber, you destroy habitat. When you destroy habitat, you eliminate species. When you eliminate species, you can lead to things like, obviously, extinction. So, and is that happening? Yeah, but it's not just animals. Remember, it's plants as well. And that's important because that's where most of our medicines come from, is from plants. So destroying ecosystems is a particularly bad idea. And we've been destroying the Amazon basin, for example. Much of the forested areas of the United States had been removed. So this has been a significant impact. And I mention the United States because I don't want you to think like, oh, it's just happened in other countries. No, it happened here as well. So there's an argument that plantation harvesting is better, so that many forests have been cut down and then replaced with plantations. Did a lot of this in the South. I've visited some of those up in Oregon and Washington. Of course, the best thing to do is recycle paper. Can paper be infinitely recycled? No. The reason why is because as paper gets recycled, the fibers get shorter and it becomes less valuable. But nonetheless, paper can still be recycled, which would reduce the need for eliminating forest. So some of the product issues with timber is that we can manufacture things like medium density fiberboard and plywood. The problem is that we have to apply resins and glues to these products, which then make it virtually impossible to recycle. And then there's the probable carcinogens which come from resins and glues that are in these different products. However, well, the other reason why they do this is because you can cut down trees much younger, and then rather than making timber products, meaning 2x4s, 4x4s, 4x6s, you grind it up and then you mix it with a chemical like resin to make wood products. So the possible solutions to this is, well, then replace it with things like recycled plastic lumber. We have a lot of this plastic. We can manufacture lumber out of it. And the stuff's fantastic. When you can leave it outdoors, you don't have to worry about replacing it. It's not going to rot. And you can make it with grooves in it so people don't slip on it. You can have it in any color you want. You can also replace timber products with steel studs. Been a lot of buildings getting built with steel rather than wood because steel costs less and the steel is recycled. Steel is the most recycled material there is. And then there are some other possibilities as well. So other design strategies would be that an industry that purchases timber would specify the use of plantation or recycled timber. They would avoid this non-sustainably harvested rainforest timber by relying on some of these organizations that certify timber as being okay for the environment, like the Forest Stewardship Council. And there's also the PANDA Environment.org and the Rainforest Alliance. All of them have been involved in certifying different types of plastics. Timber. Okay, so I'll talk about glass, another building material, or another material that's used to make products. It's one of the oldest products there is. Dates back over 5,000 years. To make glass, you need sand and soda ash and limestone, some feldspar, and occasionally recycled glass. You can throw that in there as well. There's a lot of products that are made out of recycled glass. And the downside is that glass requires lots of energy. There was a great recycled glass plant up in, I think it was Union City that I visited, and they were making wine bottles for, you're not supposed to know, but they were making it for Gallo. But they eventually went out of business, not because of the glass, because they could get recycled glass from the curbside recycling programs for next to nothing. The problem was the cost of natural gas. So energy costs is what did them in. So speaking of the manufacturing process, here it is here. If you want to see, you typically would take sand and soda and lime and sometimes cullet. This is the recycled glass. And then you melt this stuff down, and then you form it in any way you want. And then you get into inspection and packaging, and then eventually selling that product to your distributors. So impacts of glass is mining, energy use, which I discussed. And when you're using more energy, you produce more carbon dioxide and you create more emissions then. And then it's also, since it's heavy, it costs more to transport, which means that you have to use more fuel to transport it. And in some cases, you even pay more road taxes because trucks pay taxes based on how much they weigh. So the benefits of glass is that it's very easy to recycle. If you ever had a Budweiser or some beer that was in brown glass, it was undoubtedly that glass was made from recycled glass. Budweiser is one of the largest purchasers of glass to make a recycled glass because they know it's a great product to protect their beer. You don't want sunlight getting into beer, so the best way to do that is to have brown glass, and the cheapest way you can make brown glass is from recycled glass. Okay, so about glass recycling, how are we doing? Well, we could be better about it. The markets have not been good for glass for quite a while, mostly because it's heavy. So the solution to that is to require creating systems to recycle glass in a region or a locality, right? So that would also have to involve regulators to help allow this, but that would close major distribution systems and huge distances to move stuff, because instead you just have it being done local. When you're doing local recycling, you reduce the distance of transportation, reduces the greenhouse gases, fuel consumption, etc. Okay, so now let's talk about aluminum, another product that's widely used. It's relatively new, only since the 1800s. It's made from ore, bauxite, and then that bauxite gets transported to refineries and it's converted into this stuff called alumina. And the smelting plants then extract aluminum, and then they will make these ingots, which you see a picture of here. And then the ingots go off to fabrication plants where they will manufacture stuff like extruded materials and aluminum cans. It's not just aluminum cans. In fact, the Alcoa building, I think it's still owned by them in San Francisco, was made entirely of aluminum. They made the building out of their own product. It's a multi-story building in San Fran. So aluminum recycling, it requires processing aluminum requires lots of energy, and that's a major contributor to greenhouse gases. But aluminum is easily recovered, and it uses much less energy to recycle aluminum to make aluminum. So that means that aluminum has one of the has had, and for a long time has had, the strongest recycling market of any other material. And they recycle it not because of the material, but because it uses so much less energy to make aluminum from aluminum. So let's talk a little bit about steel and metals, right? So it's one of the oldest materials, iron and steel, that is. We can find some ancient swords. Swords were made from steel. Then there's more recent materials like copper and manganese, nickel and chromium. So the main steps in all these materials is the mining and processing of the ore, and then all the steps that were involved to make it. Of course, you can see there's massive environmental impact when you destroy an entire mountainside to extract the material to get the ore. So how do we make steel? Well, you have to have a furnace, and the electric arc furnaces are much more efficient. In fact, in the United States, furnaces have been switching to electric arc because they use so much less energy, and but they are using 100% recycled steel. So in the U.S., that's what we're manufacturing here, is mostly recycled steel. So when you recycle steel, you save about 2,500 tons of ore, 1,400 pounds of coal, 120 pounds of limestone. So you can see significant differences. So much of the automobiles and structural steel and rebar, appliances, cans are made of recycled steel or have significant parts of it. So a strategy here to improve our use of steel is to use recycled steel, lightweighting as always, and to segregate steel from other materials, all of which is very easily done. So we'll talk a little bit about paper. So here's the a scheme here of paper making. From the plantation, debarking, chipping, a refinery, a refiner that grinds this stuff up, and then it gets into the paper making process. We'll make things like newsprint, or then they have other types of paper. There's white ledger, and on and on and on. Curbside collection once it's disposed of, Canadian curb here, and then after collection, paper has to get de-inked and then screened, and then it can be pulped and then go back in. So closed loop industrial ecology type system here. The impacts of paper, of course, back to deforestation, and then in producing these forests, there's a lot of pesticides and herbicides that's used. In the manufacturing, there's solid waste and suspended solids like the lignin has to be removed, and then there's bleaching and chlorine and dioxins that are created. So we have these significant types of water pollutants. So deforestation, water pollutants. The good news is that more than half of paper is now being from a regeneration forest or plantation forest. Paperboard consumption's been declining. Of course, it was extraordinarily high because of the invention of printers, right? Personal printers greatly increased the amount of paper that was consumed, and it's expected that we'll be using much less paper as people engage more with electronics and saving documents and sharing documents online, where documents don't need to be printed. Okay, so improvement would be then using only, when it says brightness, what that is referring to is there's different qualities that are associated with paper. So you may not need to use the absolute best paper when you're printing. You could use recycled paper and it'll be just fine. And then the other possibility is to use alternatives to paper made from forest. You can make paper from things like kenaf and hemp. Okay, so the next thing we're looking at as an eco-design strategy is avoiding hazardous materials. So you wouldn't want to be using or reduce the amount of materials that are known to be hazardous or generate hazardous waste in the life cycle. So that would be these things here: toxic materials that are toxic, flammable, corrosive, reactive, ozone depleting, or those that contribute to global warming. So the toxic materials that are out there are things like lead, and nickel, and mercury, arsenic, chromium. There's formaldehyde that's used in papers and fiberglass and flooring materials and textiles. Then there's chlorinated organic solvents, things that are in paints and paint strippers and glues, which are being reduced greatly because of a state legislation in California that required paint manufacturers to take back paint. When they were taking paint back, they wanted to reduce the amount of chemicals in it. And also they had been hit up with lawsuits about lead in paint, so that's been removed. So by having them be responsible for the product, that has greatly reduced the amount of chemicals, toxic materials that are being used. And then there's other things as well. You can see the brominated fire retardants, and so in Europe they passed the restriction of hazardous substances, or RoHS, which we'll talk about later in the course. And the EU and China will be key players in how this will work out. So other things that would work to reduce is atmospheric pollutants like these ozone depleting substances, refrigerants. So chlorofluorocarbons or CFCs have been eliminated from the production processes, but HCFCs are still being used, and we need to do more research into seeing how we can replace those. PERC, or perchloroethylene, is also an atmospheric pollutant. Many dry cleaners are removing PERC and no longer using it. And then we have to be concerned about these other global warming gases: CO2, methane, nitrous oxide, chlorofluorocarbons, hydrochlorofluorocarbons. If we can use less material that are global warming gases, the better off the design process. So clean, right? We want to get to cleaner processes. Basically, produce less waste, and using research and development to identify where we can reduce these wasteful products and processes, and then working with purchasing staff to identify green suppliers and how to extend producer responsibility throughout the supply chain. So here's some good news. Nike, they were using organic solvents and adhesives and primers and degreasers. Toluene was one of them in their production of shoes. And then they began development of water-based materials in '92 and implemented them in '95. And after they did that, they reduced their solvent use by nearly 90%. And that saved them money as well, about $4.5 million. And there's another benefit here with solid waste reduction. All of the rubber waste in China had been discarded, but then in September they started to recycle that waste. So 90% of that was recycled, and so big improvement there. Actually, I had a pair of those shoes. They were called Nike Regrind. They were great shoes. Okay, so other things about maximization of energy efficiency. So we want to look at how can you make products and use less energy. Using less energy means less cost. Less cost means more profit for the business. So you would look at, and it saves money for me and you, right? If you make energy efficient products, so people like me and you will spend less money on energy. I recall once when I replaced a refrigerator, an old electric refrigerator and an old electric dryer with a new refrigerator and a gas dryer, and within, it was about 3-4 months, I had recovered all the costs it took to buy the product in the first place. So that meant from that period on, I was reducing the amount of money that I was spending on energy, as well as having paid for the product. So it's like I got the products for free, and now I'm spending less. And when I'm spending less, what that means is that I now have more money. And when I have more money, I can do more things like buy candy or go on a trip. Okay, so other things about energy efficiency: eliminating waste by having good insulation, and then other things we'd be looking at with energy is using cleaner energy sources, the renewables, of course, solar and wind, geothermal are all possibilities. Also using things like reusable, rechargeable batteries. All of that's helpful. And then we'd also look at maximizing water efficiency. So in a business, that could be recycling water, clean it up, and then when using it in your process, so you don't have to continuously use water and waste it. I was involved in the 1980s with developing water conservation standards in California, and those rules that were adopted then have saved probably in billions and billions of acre-feet of water, simply because people use less, because they use less water in showers, because I wrote a regulation that changed that. So if we want to look at waste minimization, the first thing to do is looking at source reduction, meaning make less in the first place. So that's up here, right? This first, the biggest part of the triangle. And so that means there'd be less mining, less extraction of materials, less harvesting of product or of the raw resources. So that's the key, is where industry uses less in the first place. Simplifying the product, lightweighting the product, using less packaging, using fewer materials. And another thing here about waste minimization is making products last longer. The longer it lasts, the less need there is to buy a new one. I'm always kind of amused by these people who will replace their car with a Prius. I can see it when your car needs to be replaced, but if you just buy a new car thinking you're going to make better for the environment, they don't consider the vast amount of resources it took to manufacture the car in the first place. So if you need a car, that's when you should consider things like an electric vehicle or a hybrid vehicle. But if you're thinking you're going to make the environment better by replacing your current car that works fine, you'd be wrong. Okay, so I have this graphic here of a copy machine, because these things are notorious for breaking down. So waste minimization is key, and so making a product better can make the need for having new products manufactured. And the other things you would do is design these products for maintenance and repairability, and to be upgraded as well. Electronics come to mind with that. Many computers cannot be upgraded or difficult to upgrade. And so we end up having to discard them and have to buy new ones. Other things about waste minimization is product reuse. So can we design things like boxes for transportation that can be reused, as opposed to getting home deliveries, and where we get boxes, then we just have to throw these boxes away, putting them into the recycling stream. There's this company called Loop, and they've made this a reusable shipping container. I haven't seen one in real life. I've just read about them. The key is going to be what Amazon decides to do, since they control this vast majority of the market of home delivery. Also eBay has been working on these too. So another component of waste minimization then would be product remanufacture. So there's stuff like retreaded tires, which I have not seen in years, but there used to be quite a few of them that were out there. And then the automobile industry has done a good job with restoring product characteristics to new. So here's a transmission and a starter. Typically, if you need a new starter or a tranny, you get one that's been remanufactured. Batteries are also, automobile batteries are also tend to be recycled content. So another is minimizing consumption. So this is the guy here from Dyson Vacuums. He eliminated the need for having bags, so now that's one less thing that gets thrown away. And efficiency, creates for more efficiency. What we need to do more about is refillable ink containers, and of course you're very familiar with the reusable water bottle. So now the idea here is minimizing the impact of disposal by designing things for, in some cases, degradability, but in most cases for recyclability, right? And things that are that will be discarded to make compost, they cannot contain toxics, so you don't want heavy metals used in printer inks, things like that. And then even if it had instructions, one of the keys for the consumers is, will they read them and will they follow them? I tend to think that no, they don't, and then they won't. And then the last thing about this stuff, if you're going to have things that are designed for degradability, you have to have cities that will have programs to collect this stuff where it can be brought to a place where it can be then degraded and made into a soil. So recycling sources tend to be industrial waste, post-consumer waste, and post-consumer domestic waste, which we've talked about a bit before. All right, so that's it. Hope you enjoyed this lecture, and I'll catch up with you on the next one.